What if I told you that everything you know about time is a lie? That the past, present, and future aren't separate, but exist together in one seamless flow, right now. Sounds like science fiction, doesn't it? But here's a fact to shake your perception of reality. According to Einstein's theory of relativity, time is not a constant. It bends, stretches, and twists depending on how fast you're moving or how close you are to a massive object. That means your now could be someone else's past or future. Think about this. Astronauts aboard the International Space Station actually age slower than people on Earth. This phenomenon, called time dilation, is real and measurable. But it's only the tip of the iceberg. If time isn't fixed, if it's relative and intertwined with space, then what does that say about how we experience it? What if the timeline you're living on is just one perspective? Could the past and future be happening simultaneously, right alongside you? Stick around, because we're about to unravel a mind-bending truth that could completely reshape how you think about existence. From Einstein's groundbreaking revelations to the latest quantum theories, we'll explore the bizarre, mysterious structure of time. By the end, you won't just be questioning what time is, you'll be questioning whether it exists at all. If the universe itself doesn't see time as a straight line, why should we? Prepare to step into a world where clocks don't tick, calendars are meaningless, and reality is far stranger than it seems. Are you ready to take that journey? Time feels so real, doesn't it? From the moment you open your eyes in the morning to the minute you fall asleep at night, the rhythm of time shapes your every move. The clock ticks forward, marking each second as if it's carving reality into neat little pieces. But have you ever stopped to wonder, what if time isn't what it seems? What if the idea of time marching forward, second by second, is nothing more than an illusion? Take a moment to think about it. Right now, as you're listening, time feels linear, like a river flowing in one direction. We experience it as past, present, and future, a sequence that seems as natural as breathing. It's how we organize our lives, how we remember what's happened and anticipate what's to come. But what if this familiar framework is just a story we tell ourselves to make sense of the chaos around us? What if time isn't moving at all? What if past, present, and future aren't distinct realities, but instead coexist in ways that defy everything we think we know? It's a fascinating, almost unsettling idea. Imagine standing still in a river that doesn't flow, but somehow feels like it's rushing by. That's the paradox we're diving into today. The notion that time itself might not exist the way we perceive it. It's not just a philosophical puzzle. It's a concept grounded in cutting-edge science and quantum mechanics, and it could change the way you see everything. To unravel this mystery, let's start with something simple. Think about a clock. It's a familiar object, one that governs our lives, whether it's the alarm waking you up, the countdown to a big event, or the way hours seem to drag when you're waiting for something exciting. Clocks measure time, right? But here's the twist. Are they actually measuring time, or are they just marking changes? A clock doesn't prove that time is moving forward. It's simply a tool, a system of gears and hands, or digits, if you're looking at your phone, that divides our experiences into manageable pieces. The truth is, the clock isn't showing time, it's showing events. Let's dig a little deeper. Imagine flipping through a photo album. Each picture captures a moment, a smile, a sunset, a celebration. When you flip through them quickly, it feels like a story is unfolding, like time is flowing from one moment to the next. But if you were to stop and really look, you'd realize that each photo exists independently. The past isn't gone, it's still there, captured in that image. The future isn't here yet, but it's waiting, just out of reach. And you, in the present, are flipping through the pages. Now think about this. What if reality works the same way? What if every moment, past, present, and future, exists all at once, like the pages of that album, and we're just flipping through them? This idea isn't as far-fetched as it sounds. Physicists have long debated the nature of time, and many believe that it's not an absolute thing but a human construct, a way for our brains to make sense of an incredibly complex universe. In fact, Einstein's theory of relativity was one of the first to challenge the traditional view of time. He showed that time isn't universal. It's relative, stretching and contracting depending on speed and gravity. For example, astronauts on the International Space Station age a tiny bit slower than people on Earth because of the weaker gravitational field in orbit. It's a phenomenon known as time dilation, and it's a mind-blowing reminder that time isn't as straightforward as it seems. But Einstein's relativity was just the beginning. Today, quantum physics is taking things even further, pushing the boundaries of what we thought we knew. One of the most intriguing concepts is the idea that time might not exist as a fundamental part of the universe. In the quantum realm, particles don't follow the neat, predictable paths we're used to. Instead, they exist in states of probability, occupying multiple positions or outcomes at once until they're observed. This strange behavior has led some scientists to question whether time itself is an illusion, a byproduct of how we perceive these probabilities collapsing into reality. It's a radical idea, but it's not without evidence. For example, experiments in quantum mechanics have demonstrated that particles can be entangled, meaning their states are linked, no matter how far apart they are. If you change one particle, the other reacts instantly, even if they're on opposite sides of the universe. This phenomenon, known as quantum entanglement, seems to operate outside the bounds of time, as if past and future don't matter. How can something happen instantly across vast distances if time is supposed to be linear? It's a question that challenges everything we think we know. Another fascinating concept is the block universe theory, which suggests that all moments in time, past, present, and future, exist simultaneously. Imagine the universe as a giant loaf of bread, with each slice representing a moment in time. From our perspective, we're moving through the loaf, experiencing one slice after another. But in reality, the whole loaf is already there. Every slice, every moment, exists all at once, and the flow of time is just an illusion created by our limited perspective. Think about what this means. If the block universe theory is correct, then the past isn't gone, and the future isn't something that's yet to happen. They're both already there, as real and unchanging as the present moment you're experiencing right now. It's a mind-bending thought, one that raises profound questions about free will, memory, and even the nature of existence itself. Are we truly making choices, or are we simply following a predetermined path through the slices of that loaf? As we journey further into this mystery, it's worth reflecting on why this idea feels so strange. Time is deeply woven into the fabric of our lives. It's how we measure progress, how we make sense of change, and how we define ourselves. We say things like, "Time heals all wounds," or "Time flies," and we believe them because they fit our experience. But what if those experiences are just a trick of perception? What if time doesn't flow, and instead, we're the ones moving through a timeless reality? This isn't just a question for scientists or philosophers. It's something that touches every aspect of our lives, from the way we think about the past to the way we plan for the future. If time is an illusion, then what does it mean to live in the moment, to cherish memories, to dream about what's to come? These are questions we'll explore in this video, and by the end, you might find yourself looking at the clock or the universe in a completely new way. So, buckle up. This is more than just a thought experiment. It's a journey into the very nature of reality. And who knows, you might discover that time isn't something you're running out of. It's something that never existed in the first place. Ready to rethink everything you thought you knew? Let's dive in. For as long as humans have gazed up at the stars or watched the sun rise and set, we have been haunted by one enigmatic question. What is time? It is a question so deceptively simple that even a child might ask it, yet so profound that some of the greatest minds in history have struggled to answer it. To understand time, ancient civilizations turned to the heavens. They tracked the movements of the sun, the moon, and the stars, crafting calendars to divide their lives into days, months, and years. Time became their invisible guide, a force that ordered their existence. Yet even then, the question lingered. Was this concept of time something intrinsic to the universe, or was it simply a human invention to bring order to chaos? For centuries, the prevailing view was that time was absolute. This idea found its champion in Isaac Newton, whose groundbreaking work in the 17th century laid the foundation for classical physics. Newton saw time as a universal constant, a steady and unchanging backdrop against which all events unfolded. To him, time was like a river, flowing in one direction, carrying everything along its current at a uniform pace. It was predictable, reliable, and independent of everything else. This vision of time resonated with the orderly, mechanical view of the universe that dominated the scientific thinking of the era. It seemed logical, and most importantly, comforting. Time was immutable, a universal truth that didn't care where you were or what you were doing. For centuries, this idea of absolute time held sway. But then came Albert Einstein, and with him, a revolution in our understanding of reality itself. In the early 20th century, Einstein introduced his theory of relativity, which fundamentally altered how we perceive time. To Einstein, time wasn't a universal constant at all. Instead, it was relative, intertwined with space, and subject to change depending on speed and gravity. Imagine standing still while a friend zips past you in a spaceship at nearly the speed of light. To you, a second might feel like, well, a second. But for your friend, that same second could stretch into minutes, hours, or even years. Time, Einstein showed us, is elastic. It bends and stretches like a rubber band, influenced by the very fabric of the universe. This idea, though mind-bending, has been proven time and again. Atomic clocks placed on airplanes tick ever so slightly slower than those left on Earth. GPS satellites, orbiting high above our planet, must account for the distortions in time caused by both their speed and the weaker pull of gravity. These aren't abstract theories, they're measurable phenomena playing out in the real world. Einstein's revelations dismantled Newton's comforting view of time as an unchanging constant. Suddenly, time was no longer a steady river, but a dynamic, ever-shifting landscape. And yet Einstein's theories raised even more perplexing questions. If time can bend, stretch, and even stop under the right conditions, is it truly real in the way we've always thought? Or is it merely an illusion, a mental construct designed to make sense of a chaotic universe? Think about the lines on a map. They're useful for navigation, but they're not actually there in the world. Could time be like that? Something we've invented to impose order on reality? Consider this. We often think of time as a sequence of events, past, present, and future, marching forward like soldiers in a parade. But quantum physics suggests that this might not be the case. Some interpretations propose that all moments in time coexist simultaneously. The past hasn't gone anywhere. The future isn't something waiting to happen. Instead, they're all happening right now, in a strange, timeless tapestry. If that's true, then our perception of time's passage is just that, a perception, not a reality. This idea isn't just a theoretical curiosity. It has profound implications for how we understand our lives. Think about memories. We experience them as echoes of the past. But where do they truly exist? Are they just electrical signals firing in our brains? Or are they evidence of a deeper connection to moments that still exist somewhere in the fabric of the universe? And what about the future? When we make plans or imagine what's to come, are we genuinely creating something new? Or are we merely navigating a path that's already been laid out? Even in our everyday lives, time behaves in ways that feel paradoxical. Have you ever noticed how time seems to fly when you're having fun, but drags endlessly when you're bored? Or how a single moment of terror can feel like an eternity, while years can pass in what feels like the blink of an eye? These subjective experiences of time hint at its fluid nature, challenging the idea that it's a fixed, measurable entity. They remind us that time is as much about perception as it is about physics. Philosophers have long grappled with these questions too. The ancient Greek philosopher Zeno famously posed paradoxes that challenge our understanding of time and motion. In one, he argued that to reach any destination, you must first cover half the distance, then half of what remains, and so on, infinitely. If this is true, how can you ever reach your goal? While modern mathematics resolves this paradox, it still forces us to confront the strange, almost surreal nature of time. Religious and spiritual traditions offer their own perspectives. Some view time as cyclical, a wheel that turns endlessly, bringing the past, present, and future together in an eternal loop. Others see time as a journey with a clear beginning and end, tied to the story of creation and ultimate destiny. These interpretations, though varied, share a common thread. They acknowledge that time is deeply mysterious, perhaps even beyond human comprehension. And then there's the question of free will. If time is an illusion, or if the past, present, and future coexist, what does that mean for our choices? Are we truly free to shape our destinies, or are we merely actors playing out a script that's already written? Einstein himself believed in a deterministic universe, where the flow of time is an illusion and everything, past, present, and future, is set in stone. The distinction between past, present, and future, he once said, is only a stubbornly persistent illusion. But if time isn't real in the way we think, then what is it? Physicists and philosophers alike continue to grapple with this question. Some propose that time emerges from the fundamental interactions of particles, like a shadow cast by deeper underlying processes. Others suggest that time is a property of our consciousness, a way for our brains to make sense of the universe. And still, others argue that time doesn't exist at all, at least not as we understand it. These debates aren't just academic. They touch on the very core of our existence. Time shapes everything we do, from the mundane routines of daily life to our deepest hopes and fears. It governs the rhythms of nature, the ticking of clocks, and the beating of our hearts. Yet, for all its influence, time remains one of the greatest mysteries of the cosmos. What is it? Where does it come from? And perhaps most intriguingly, could we ever live without it? As we delve deeper into this question, we find ourselves confronting not only the nature of time, but also the nature of reality itself. Is the universe a clockwork mechanism, ticking away in perfect order? Or is it something far stranger, a realm where time is fluid, flexible, and ultimately an illusion? These are the questions we must explore as we continue our journey to understand the true essence of time. The answers may change not only how we see the universe, but also how we see ourselves. Let's break it down step by step. Imagine time as a river, flowing steadily from the past to the future. This is how we intuitively experience it, each moment passing by never to return as we journey forward. But what if that isn't the full picture? What if time doesn't flow at all? Modern physics suggests a revolutionary perspective. The past, present, and future might coexist all at once, like slices in a loaf of bread. This concept, known as the blocked universe theory, challenges everything we think we know about time. According to this theory, every moment of your life, your first laugh, your first love, and even your final farewell, is already out there, permanently fixed in the fabric of reality. Rather than events unfolding as you live, it's as if all of time already exists. You're simply moving through it, one slice at a time. Think of each slice as a snapshot, capturing every moment with precision, from the microscopic arrangement of atoms to the grand scale of the cosmos. These snapshots aren't fleeting, they're eternal. To understand this better, let's zoom out. In our everyday lives, we perceive time as linear. We remember the past, experience the present, and anticipate the future. But this perception may be a result of how our brains process reality, rather than how reality functions. The blocked universe theory suggests that all moments are equally real. Just as every page in a book exists at once, but you read them one at a time, all events in time exist simultaneously. The difference is, unlike a book, you can't flip back or skip ahead, at least, not yet. One of the most fascinating aspects of this idea comes from Einstein's theory of relativity. Einstein demonstrated that time isn't a universal constant, it's relative. The rate at which time flows can change depending on your speed and gravitational field. For instance, time moves slower for someone near a black hole compared to someone far from it. This discovery undermines the notion of a single, unified now. If time can stretch and compress, does it even make sense to talk about a flowing river of time? Or is it more accurate to describe time as a static landscape, where your position depends on your perspective? This idea doesn't just shake up physics, it transforms our understanding of existence. If all moments already exist, what does that mean for free will? Are we simply passengers on a preordained journey, following a script that's already written? Or is there still room for choice and change within this structure? These questions are at the heart of the blocked universe debate, blending science, philosophy, and the mysteries of human experience. So the next time you picture time, don't think of a river. Instead, imagine a loaf of bread. Every slice is out there, waiting for you to pass through, one moment at a time. Sounds wild, right? But let's back up. How did we even get here? The Newtonian view of time. In the 17th century, Isaac Newton introduced a groundbreaking perspective on time. To Newton, time was like an invisible, universal stage, a steady, unchanging backdrop against which the events of the universe played out. He imagined time as absolute, flowing at a consistent and predictable pace, independent of the happenings within the cosmos. It ticked forward unerringly, neither slowing down nor speeding up, no matter the circumstances. This concept resonated deeply with the scientific community of his era. It provided a straightforward way to think about the nature of time, uniform, objective, and unaffected by external factors. Newton's absolute time was intuitive, elegant, and aligned with everyday human experiences. People could look at a clock and trust its steady rhythm as a reliable measure of time, regardless of where they were or what was happening around them. It became the foundation of classical mechanics, the branch of physics Newton pioneered. With this framework, he explained the motion of planets, the behavior of falling objects, and the principles that govern the physical world. For centuries, Newton's view of time stood unchallenged. It was embedded in the way scientists understood the universe and how people organized their lives. It worked remarkably well for most practical purposes, from measuring the duration of a journey to timing the swing of a pendulum. Its simplicity made it accessible to everyone, from scholars to sailors navigating the high seas. The ticking of a clock mirrored the regularity of Newton's time, offering a sense of order and predictability in a seemingly chaotic world. But despite its widespread acceptance, cracks began to appear in Newton's framework. As scientists delved deeper into the mysteries of the universe, they encountered phenomena that Newton's absolute time could not explain. The assumptions that had once seemed so unshakable began to feel inadequate in the face of discoveries. One major challenge came from the behavior of light. Experiments in the 19th century revealed that light traveled at a constant speed, regardless of the motion of the source or the observer. This was puzzling because it contradicted the idea of absolute time and space. If time were truly absolute, the speed of light should vary depending on the observer's motion relative to the source. Yet, experiments showed otherwise. Light seemed to defy Newton's laws, maintaining a steadfast speed that could not be reconciled with the classical understanding of time. The problem didn't stop there. As technology advanced, scientists began to investigate phenomena that occurred under extreme conditions, near massive objects, at incredibly high speeds, or in the vastness of space. Observations from these investigations painted a picture of the universe that was at odds with Newton's ideas. One of the most striking examples came from the study of gravity. Newton himself had described gravity as a force acting at a distance, pulling objects toward one another. He believed that this force operated instantaneously, with no delay, across any distance. But as scientists examined gravitational interactions more closely, they noticed something curious. Time seemed to behave differently in the presence of massive objects. Clocks placed near a strong gravitational field ticked more slowly than those farther away. This phenomenon, known as gravitational time dilation, was completely incompatible with Newton's vision of absolute time. Another challenge arose from the study of high-speed motion. Newton's framework assumed that time was the same for all observers, regardless of their speed or direction of travel. But experiments involving objects moving at speeds approaching that of light showed otherwise. Time appeared to slow down for these fast-moving objects, a phenomenon now known as time dilation. This effect, though imperceptible in everyday life, became increasingly significant as speeds increased. These findings highlighted a fundamental flaw in Newton's concept of time. It was too rigid to accommodate the complexities of the universe. While it worked well for describing the motion of planets or the fall of an apple, it couldn't account for the behavior of light, the effects of gravity, or the distortions of time at high speeds. The universe, it seemed, was far more intricate than Newton had imagined. The limitations of Newton's absolute time became even more apparent in the 20th century when a new scientific revolution reshaped our understanding of the cosmos. Albert Einstein's theory of relativity challenged the very foundation of Newton's ideas. Einstein proposed that time was not absolute but relative, depending on the observer's frame of reference. He introduced the concept of spacetime, a four-dimensional fabric that combined space and time into a single entity. In Einstein's universe, time could stretch, compress, or warp in response to the presence of mass, energy, or motion. Relativity provided a framework that could explain the phenomena Newton's theory could not. It showed why time slows down near massive objects or at high speeds, offering a deeper understanding of the universe's inner workings. Yet, even as Einstein's ideas gained acceptance, Newton's vision of time remained influential. It continued to serve as a useful approximation for many practical applications, from engineering to everyday life. Reflecting on Newton's contributions, it's clear that his ideas were not entirely wrong, they were simply incomplete. His concept of absolute time was a stepping stone in humanity's journey to understand the cosmos. It laid the groundwork for the scientific advancements that followed, providing a foundation upon which future generations could build. In hindsight, Newton's view of time can be seen as a product of its era. It emerged in a world that valued simplicity, order, and certainty. It offered a sense of stability in an age when the universe seemed vast and mysterious. Even as we move beyond Newton's framework, his influence endures, reminding us of the power of curiosity and the importance of questioning the world around us. Today, we understand time as a dynamic, flexible dimension, intricately linked to space and influenced by the forces of the universe. But the journey to this understanding began with Newton, who dared to ask, "What is time?" His answer, though imperfect, set the stage for the discoveries that would follow, propelling humanity toward a deeper understanding of the cosmos. And so, while Newton's absolute time may no longer hold, its legacy remains. It taught us to seek patterns, to question assumptions, and to strive for knowledge. In the ever-evolving story of science, it serves as a reminder that each discovery, no matter how flawed, is a step toward the truth. In 1905, Albert Einstein published his special theory of relativity, shattering Newton's concept of absolute time. Einstein showed that time and space are intertwined in a single fabric called spacetime. Here's where it gets interesting. The faster you move, the slower time passes for you. This is called time dilation. For example, astronauts on the International Space Station age slightly slower than people on Earth because they're traveling at high speeds. But it doesn't stop there. Einstein's general theory of relativity took things further, showing that massive objects like planets and black holes warp space-time. This warping can stretch time so much that it almost stops. Near a black hole, for instance, a second from close to the event horizon could equal years for someone far away. Time, it turns out, is not universal. It's flexible, relative, and deeply connected to the fabric of the universe. The block universe. When we think about time, we tend to view it as something that flows, constantly moving forward. Each moment follows the next in an endless progression. The past becomes the present, and the present soon turns into the future. This movement is so ingrained in our experience that it feels natural, like something we can't question or change. But what if this idea of time flowing is all just an illusion? What if time doesn't move at all? Enter the block universe theory, a fascinating concept that challenges the conventional view of time. This theory suggests that time, as we understand it, isn't actually a river flowing in one direction. Instead, it argues that all moments, past, present, and future, exist simultaneously, like frames in a film reel. The moments you experience as now are just one part of a much larger picture, where everything is already laid out in a fixed, unchanging block. You might feel as though time is progressing forward, but in the block universe, that feeling is nothing more than an illusion. So what exactly is the block universe theory, and how does it challenge everything we know about time? What is the block universe theory? The block universe is rooted in the idea of eternalism, which is a philosophical view of time. Eternalism asserts that all moments in time, past, present, and future, are equally real. This is in contrast to presentism, which holds that only the present moment is real, and the past and future are non-existent. Imagine time as a giant block, or a four-dimensional object, with the three dimensions of space and the fourth dimension being time. In this block, every moment in history exists as a point, and every event, whether it's from the past, the present, or the future, is fixed in place. Just as every point in space has a specific location, Every point in time has a specific moment, and all of them coexist in this block. In the block universe, the past doesn't vanish into nothingness once it's gone. The future doesn't remain uncertain and undefined until it arrives. Everything is laid out, and every moment exists in its own right, waiting to be experienced by an observer. The flow of time that we perceive is just a subjective experience, not an objective feature of reality. But how does the block universe relate to the idea of time as an illusion? Well, the central idea behind the block universe is that time doesn't move or pass at all. The feeling of time flowing is just that, a feeling. It's our limited, human perspective that makes it seem as though moments are disappearing or unfolding. In truth, all moments are already there, existing in the block, unchanging and eternal. Think about the way a movie works. When you watch a film, you see a series of images flashed in front of you, one after the other. These images represent moments in time, but the film itself doesn't move or flow. The images are already present on the film reel, and they simply exist, whether you're watching them or not. Similarly, in the block universe, all moments in time exist in a kind of timeless present. To us, it feels like time is constantly moving forward, but that's because we can only perceive the present moment. We're not aware of the past or future in the same way we are of the present. However, the theory suggests that if we could somehow step outside of our limited perspective, we would see that all moments, past, present, and future, are equally real and unchanging. The future is already laid out just like the past, and the present is merely a fleeting moment that we happen to experience. An analogy, the photo album. One way to think about this is by using an analogy, a photo album. Imagine that you have a photo album filled with pictures of your life. Each photo represents a specific moment in time, a birthday, a holiday, or a special event. As you flip through the album, you see each picture, one by one. The photos don't change, they don't disappear after you look at them, and they don't become something else. They just exist, capturing a moment in time. Now, imagine that your entire life is in this album. All the moments from your past, present, and future are represented by these photos. The photos don't fade away, and they don't change as you turn the page. They're all still there, whether you're looking at them or not. The album is complete, and every moment in your life is already contained within it. This is similar to the way the block universe works. The past, present, and future are all part of the same block. They don't disappear, and they don't change. They simply exist as fixed moments, with no actual flow or movement from one to the next. It's our perception that makes us think time is moving forward, but in reality, it's just our minds jumping from one moment to the next, like flipping through the pages of a photo album. If the block universe is true, it has some profound implications for how we understand reality. For one, it suggests that free will may not be as straightforward as we think. If all moments in time are already fixed, then the future is already determined, and our choices may be just as predetermined as the past. But this doesn't necessarily mean that life is without meaning. Even if the future is already laid out, we still experience it in a way that feels real to us. The choices we make and the moments we live are still significant because they're part of the grand, that eternal block. The block itself may be unchanging, but our experience of it, our consciousness and the way we move through time is still real. This also raises the question of whether we can ever truly experience the future or revisit the past. In the block universe, the past is just as real as the present, and the future is equally set in stone. However, we can only access the present moment. The future remains out of reach, and the past is no longer accessible. We're trapped in our limited perspective, unable to perceive time as it truly exists. Is time really an illusion? At this point, we're left with a big question. Is time an illusion, or is it just a limitation of our perception? According to the block universe, time is indeed an illusion, but not in the way we typically think of it. It's not that time doesn't exist, but rather that the flow of time is something our minds create to make sense of the world. Time itself is timeless, existing outside of our perception, with past, present, and future all coexisting as part of a larger, eternal block. This brings us back to the question of how we experience time. If the block universe is correct, then our experience of time is like watching a movie. We see one frame at a time, and it feels like the story is unfolding. But in reality, the entire movie is already there, and it's already been played. We're just watching it unfold from our limited perspective, unaware of the entire picture. It's a humbling thought, the idea that we're trapped in our perception of time, unable to access the entirety of existence. And yet, the theory also suggests that there's something deeply comforting about this idea. If time is an illusion, then maybe we don't need to worry about the future or lament the past. They are just as real as the present, and they all exist as part of the same eternal block. Time is still real, but not as we know it. The block universe theory challenges everything we think we know about time. It suggests that time isn't a flowing river, but a fixed, unchanging block where past, present, and future coexist. Time, as we perceive it, is nothing more than an illusion, one that our minds create in order to make sense of the world. But while time may be an illusion in this sense, it's important to remember that our experience of it is still very real. The moments we live, the choices we make, and the events we experience all matter. The block universe may reveal that the future is already laid out, but that doesn't diminish the significance of our existence. So next time you feel like time is slipping away from you, remember the photo album analogy. Your life, your past, your future, and everything in between are all part of the same eternal block. Time may not flow, but it still has meaning. And maybe that's enough to help us live with a little more peace of mind, knowing that every moment, every choice, and every event is already part of the grand picture that is the universe. Time and entropy. Time has always been a curious concept. We live our lives as if time moves forward. Moments pass, the future arrives, and the past becomes history. But when we think about the essence of time itself, things get more complicated. If time doesn't have a direction, why do we perceive it as flowing? This is where the concept of entropy comes into play. Entropy is essentially a measure of disorder or randomness in a system. The second law of thermodynamics, one of the fundamental principles of physics, asserts that entropy tends to increase over time. To understand how this works, let's look at a simple example. Imagine you have an egg. When you crack the egg and scramble it, the once neatly contained yolk and egg white spread out into a disordered mess. You can't unscramble the egg, it's irreversible. This movement from a highly ordered state, the whole, unbroken egg, to a more disordered one, scrambled eggs, reflects an increase in entropy. The scrambled egg represents a state of higher entropy, where the system is less ordered than before. Now consider this idea in the context of time. Entropy helps explain why we experience time as flowing in one direction, forward. The second law of thermodynamics implies that just like our scrambled egg, the universe moves toward greater disorder. This process gives us a clear direction for the passage of time. We remember the past because it was a state of lower entropy, a time when things were more ordered. The future, which we cannot predict with certainty, represents a state of higher entropy. It's an unknown, where disorder increases and things break down. This concept offers us a logical explanation for why time seems to flow from past to future. We experience time not just because of the ticking of clocks, but because entropy increases as time progresses. Our memories, for example, are based on states of lower entropy, times when things were more ordered or structured. As time moves forward, entropy increases and the future becomes more chaotic and uncertain. It is this increasing disorder that gives time its arrow, its apparent direction from past to future. But here's a fascinating twist. This idea of time's arrow and the way we perceive it may not be as universal as we think. The arrow of time might not be a fundamental aspect of reality itself, but rather a feature of how we experience the universe. There is a theory known as the block universe, which suggests that all moments in time, past, present, and future, exist simultaneously as a kind of timeless block. In this view, time is not something that flows or moves forward. It's a static entity where every event has already happened, is happening, and will happen. If the block universe is correct, then the sensation of time flowing forward is just an illusion, a trick of perception. We might feel as though we are moving through time, experiencing the present moment as it unfolds, but this perception could be an effect of our limited consciousness. In this model, the arrow of time, our sense of moving from the past to the future, is simply how we interpret the structure of events within this block of time. The idea of the block universe suggests that all points in time exist together in a timeless structure. For example, while we might think of a specific moment in the past, present, or future as distinct, they are all just different slices of a single, unchanging whole. The past is not gone. The future is not yet here. In the block universe, they are all already part of the same reality. Our experience of time as flowing forward might just be a result of how we perceive this block, like being stuck on a moving conveyor belt, only able to see one section at a time. This theory challenges our deeply held belief that time is linear, that it has a past, present, and future that we move through. It suggests that time, in a fundamental sense, may not flow at all. Instead, what we call the passage of time is simply the way we observe our position within this vast, unchanging block of events. This raises intriguing questions about the nature of time and how we experience it. Could time be something more malleable than we think, or is our perception of its flow just a product of our brains trying to make sense of the universe? If the block universe is accurate, then the increasing entropy that gives us the perception of time's arrow may also be a reflection of our limited understanding of how time works. Entropy might be a phenomenon that we associate with the flow of time, but in the block universe, time's flow could just be an illusion created by our interaction with the events within the block. We would still experience increasing disorder, but that would be an effect of our perception rather than an actual progression of time. This idea of a block universe challenges the common view of time as a dynamic and flowing concept. Instead of time being something that moves forward, it would be a frozen structure where all events are set and unchanging. In such a universe, the future is not something that is yet to be. It's already there, just as real and unalterable as the past. We may be able to look back and see how things were, but the future isn't something that can be shaped or changed. It simply exists as part of the overall structure. Yet, despite these complexities, the perception of time's flow remains a powerful aspect of our reality. We live in a world where events unfold in a seemingly irreversible manner. We are born, we grow, we age, and we die, and through it all, time seems to move in one direction. The increase in entropy, the push toward disorder, is what gives us this sense of time moving forward, shaping the experiences of our lives. Even if the block universe is correct, our perception of time may still be an essential part of how we experience existence. In the end, the relationship between time and entropy is a paradox. On one hand, the second law of thermodynamics provides a clear explanation for why we experience time's arrow. As entropy increases, things become more disordered, and we perceive this as the passage of time. On the other hand, the block universe theory suggests that time itself may not be flowing at all, and our perception of it as moving from past to future may be an illusion. The increasing entropy we associate with time may be nothing more than the way we experience the unfolding of events within the timeless block of the universe. The truth may lie somewhere in between, where time's flow is both real and an illusion, depending on how we perceive it. Time in quantum mechanics. Time is one of those concepts that we all intuitively understand in our everyday lives. We check the clock to see if we're late, we plan our days around the hours, and we measure the passage of time by the movement of the sun across the sky. However, when you dive into the world of quantum mechanics, things get far more complicated. The strange and counterintuitive nature of quantum physics forces us to rethink even the most fundamental ideas we hold about reality, including time itself. As bizarre as it may seem, at the quantum level, particles behave in ways that challenge our traditional understanding of time, leading some physicists to ask whether time, as we know it, even exists in the quantum realm. In the everyday world, we're accustomed to seeing objects move through time in a way that seems orderly and predictable. A ball thrown in the air rises, pauses for a moment, and then falls back down due to gravity. We're used to this sequence, where cause and effect flow in one direction, forward. But at the quantum level, things aren't so simple. Particles behave in ways that defy conventional expectations. They don't follow a fixed path or exist in a specific place until they're observed. Instead, they exhibit a strange property called superposition, which allows them to exist in multiple states or locations simultaneously. This is radically different from anything we experience in the macroscopic world. To understand this, imagine a coin spinning in the air. In our everyday experience, we know that the coin will land on either heads or tails. However, in the quantum realm, before the coin lands, it can be in both states at once, heads and tails simultaneously. This is the essence of superposition. It's as if the rules of time and space that govern our larger reality don't apply at the quantum level in the same way. The implications of superposition extend beyond just the behavior of particles. It challenges our conventional understanding of how time unfolds. In the quantum world, particles can exist in multiple states, each with its own timeline, and until an observation is made, all possibilities are valid. This raises a mind-bending question. If particles can exist in multiple states at once, does time itself operate differently at this scale? And if time is not the same at the quantum level, does it even make sense to talk about time as we understand it? Julian Barbour, a prominent physicist and author, has explored these questions in depth. His view on time is radically different from what most people assume. Barbour argues that time is not a fundamental aspect of reality, but rather an emergent property. In other words, time is not something that exists independently of the universe. Instead, it arises from how we perceive changes in the universe. Time, as we know it, is a byproduct of our observations and interactions with the world around us. According to Barbour, the universe is made up of moments, each one independent of the others. These moments, which he refers to as NRAOs, exist without any inherent progression from one to the next. The idea that time flows linearly is simply a perception of how we experience change. If we could somehow step outside of our perception, we would see that time doesn't flow, but rather exists as a series of individual, static moments. Barbour's argument is based on the idea that the passage of time is tied to our experiences of change. The universe itself, he suggests, doesn't move through time. Instead, it's our perception of the universe changing, our ability to notice shifts and transitions, that gives us the illusion of time flowing. In this view, time is not a fundamental force of nature, but a way we process and make sense of the universe. Without observers or the ability to perceive change, time would have no meaning at all. Barbour's hypothesis challenges the traditional view of time as something that flows steadily and uniformly. This traditional view is deeply ingrained in how we experience the world and in the laws of physics that govern the motion of objects. The equations of classical physics, for example, assume that time flows smoothly, with one moment leading to the next. This framework works perfectly well for the everyday world, but begins to break down when we enter the quantum realm. At the quantum level, time doesn't seem to have the same continuity. Some interpretations of quantum mechanics suggest that the very notion of time may not even apply to the fundamental particles of the universe. According to quantum theory, particles exist in a state of potentiality, meaning that they are not confined to a single moment in time. Instead, they exist in a sort of timeless state until measured or observed. Once we observe them, they collapse into a definite state, and only then can we describe them concerning time. But before that moment, time as we know it doesn't have a clear role. This idea challenges our intuition about reality. If time doesn't operate in the same way at the quantum level, how can we reconcile this with our experience of time in the macroscopic world? Does this mean that time, as we understand it, is just a convenient illusion, a product of our perception rather than an intrinsic feature of the universe? The idea that time might not exist at the quantum level raises profound questions not only about the nature of time, but also about the very fabric of reality itself. If time is an emergent property, as Barbour suggests, it might mean that the universe is fundamentally timeless at its core. This could imply that everything we experience as the passage of time is just an artifact of how we perceive change within a greater, timeless framework. In this view, the flow of time might not be a universal truth, but a localized phenomenon that emerges from the way we experience the world. Just as temperature is a property that emerges from the motion of molecules, time might be something that emerges from the patterns of change that occur within the universe. Without these patterns, without observers to witness them, time would have no meaning. In the end, the question of whether time exists at all is deeply tied to the mysteries of quantum mechanics. As we continue to explore the strange world of quantum particles, we may find that our understanding of time needs to be radically redefined. What we once thought of as a constant, unchanging backdrop to the universe might turn out to be something far more elusive and mysterious, perhaps even something that doesn't exist at all in the way we've always believed. If time is truly an illusion, then the very foundation of how we understand existence is up for questioning. The notion that time, as we experience it, might not be a fundamental component of reality forces us to rethink everything we've built our lives around. It challenges the basic assumptions about how we move through the world. We perceive time as linear. The past influences the present, and the present shapes the future. But if time is not a fixed, tangible force, but rather something that our minds have constructed, then the entire structure of cause and effect could be flawed. Could it be that what we consider choices, actions, and events are merely parts of a predetermined narrative, with no true sense of free will guiding us? The implications are both mind-boggling and disconcerting. If time doesn't exist as we understand it, then everything we've ever done, every path we've ever walked, and every choice we've made could be meaningless in the grander scale of reality. Perhaps we are not the agents of our own destinies. Perhaps, as we live out our days, we are simply watching a movie that's already been written and projected before our eyes. If this idea is true, then does that mean our entire sense of self is an illusion as well? To understand this, we have to dive deeper into the concept of self and identity. Who we are, in a sense, is based on the memories of what we have done in the past and the plans we make for the future. These mental constructs form the story of our lives. But what if that story was never really ours to begin with? What if all of it, the thoughts, the actions, the memories, is simply part of a pre-existing sequence, one that has no true sense of beginning or end, just endless slices of the cosmic loaf, stacked one after the other? The idea of free will being an illusion isn't entirely new. Philosophers and physicists have been pondering it for centuries. Some argue that if the universe operates under fixed laws of physics, then everything we experience, from the formation of galaxies to the flick of a finger, is bound by those same rules. But within this framework, where does our perception of choice fit in? Are we making decisions, or are we just experiencing events that were bound to unfold, in one way or another, from the moment the universe began? One of the most profound implications of this perspective is the question of agency. If we aren't the true architects of our future, then who or what is? Is it simply the vast, underlying fabric of spacetime, the forces of nature, relentless and indifferent to human desires? Or is there some higher level of intelligence orchestrating everything, a cosmic puppeteer pulling the strings of time and existence? While the idea of a predetermined universe seems overwhelming, it's also strangely comforting in a way. After all, if everything is already mapped out, then there's no need to worry about making the wrong decision or regretting the choices we've already made. There's no pressure to get it right, because everything is already right in its own way. But here's the interesting twist in this cosmic puzzle. Even if time is an illusion, it doesn't mean that life is any less meaningful. On the contrary, the illusion itself is what makes it meaningful. If time is just a projection of our minds, then it's our perception of the passage of time that gives us a sense of purpose and significance. Our experiences, our connections with others, the love we give and receive, the moments of joy and sorrow, we live them as though they matter, because for us they do. In a universe where time flows like a river, it's the way we swim in that current, the way we navigate its rapids and eddies, that makes life beautiful. Our emotions, our relationships, our passions, these are the things that shape the fabric of our existence, even if they're all happening in a mind-bending, non-linear dance. Think about how our understanding of the universe has changed over time. Just a few hundred years ago, people believed the Earth was the center of the universe, and time was a simple, unchanging concept. But as science and philosophy have advanced, we've learned that time is far more complex than we ever imagined. Time bends and warps around massive objects, like black holes, and can stretch and compress depending on how fast we move through space. In the grand scheme of things, we're just tiny blips in the vastness of the cosmos. And yet, the moments we experience still carry weight because they're our moments. They're the moments that make up our lives. In this way, even if free will is an illusion, there's still meaning to be found in the way we experience time. The very fact that we have this perception of linear progression gives us a framework to construct our lives, even if that framework is ultimately false. It's like watching a movie knowing the ending, but still feeling every emotion, every thrill, every tear, because it's all real in the moment. We may not be the directors of our lives, but we are the actors. And those roles matter, because they shape who we are and how we affect the world around us. What's even more compelling is the idea that the illusion of time creates the possibility for change. If time is a constant, but we experience it as flowing and shifting, then our perception of change is also a crucial part of the human experience. If everything were fixed, we would live in a stagnant world where nothing could grow, evolve, or transform. But time, even as an illusion, allows for growth. It allows for learning from mistakes, for making new connections, for finding new paths and opportunities. In a way, the illusion of time gives us the freedom to grow, even if we aren't fully in control of where we're headed. So perhaps the real question isn't whether time is real or not, but how we live within it. It's not about whether we have free will or whether everything is predetermined. It's about how we experience the world and how we find meaning in a reality that might be far different from the one we perceive. The choice we have then is not necessarily about shaping the future, but about how we choose to experience the present. Time may be an illusion, but the feelings, the love, the joy, and the connection we experience within that illusion are as real as anything else. And in that, perhaps, lies the greatest beauty of all. So is time real? The answer is far more complex than we might initially think. The truth is, we don't fully know. It might be an illusion, a construct of our minds trying to make sense of a universe where the past, present, and future coexist in ways we can barely comprehend. Even the most brilliant minds in science, from physicists to philosophers, have struggled to grasp what time really is. For centuries, we've been taught to think of time as something linear, something that moves steadily forward, ticking away with every second that passes. But what if this view is just a convenient story we've told ourselves, an illusion created to help us navigate our existence? As we dig deeper into the fabric of reality, we begin to question everything we thought we knew about time. In the realms of quantum physics, time behaves in strange, counterintuitive ways. Some theories suggest that time might not even exist at the most fundamental level. Instead, it might just be a byproduct of the way we observe the universe, an emergent property of the interactions between particles and forces. In other words, time might be a creation of our consciousness, a way for us to understand events and their relationships to one another. But how could something so fundamental to our everyday experience, something we rely on to measure our lives, possibly be an illusion? It's a question that challenges not only our scientific understanding, but our very perception of reality itself. Imagine for a moment a world where time doesn't exist. What would it look like? Could we still experience cause and effect, or would everything happen all at once in an eternal present? Would our memories, the very things that define us as individuals, still hold any meaning without the passage of time to separate them? The idea that time could be an illusion opens up endless possibilities, each more mind-bending than the last. But even if time isn't what we think it is, it doesn't change the fact that it plays an essential role in how we experience life. Time might not be a fixed, absolute force, but it still shapes our lives in profound ways. It's the thread that ties together every story we've ever told, the moments we treasure, and the events that define us. Time is what allows us to plan for the future, to reflect on the past, and to understand the present. Without time, our lives would lack structure and meaning. We wouldn't know when to celebrate birthdays or when to mark anniversaries. We wouldn't have deadlines to push us to achieve our goals or the satisfaction of watching the seasons change. Even in a world where time is an illusion, it's still crucial to how we navigate reality. Yet, For all its importance, time is also something that remains elusive. It flows in ways we can't predict or control. No matter how much we try to measure it or manipulate it, time always moves forward. Even if we were to reach the ultimate understanding of time, it's likely that we would never fully grasp its nature. Maybe that's part of the mystery, the beauty of it. Time is something that transcends our understanding. Something that exists beyond the limits of our perception. It's the one thing that connects everything, from the birth of stars to the fleeting moments of our lives, and yet it's something we can never truly hold in our hands. And maybe that's okay. Perhaps it's this very mystery that gives time its power. If we knew everything about time, if we could see all of its intricacies and understand its every nuance, it might lose some of its magic. The fact that time is something we can never fully comprehend might be the very reason it captivates us. It invites us to explore, to question, to wonder. In a way, time is like the universe itself, an endless puzzle that we may never solve, but one that keeps us coming back for more. At the heart of it all, time is a reminder of our place in the vast expanse of existence. It reminds us that we are finite, that our lives are but a small blip in the grand timeline of the universe. But rather than being something to fear, this realization can be a source of inspiration. Time pushes us to make the most of the moments we have, to cherish the relationships we form, and to pursue our dreams before time slips away. It's the ultimate motivator, the force that drives us forward and gives our lives meaning. So whether time is real or just an illusion, it doesn't change the fact that it has a profound impact on us. It shapes our world, our experiences, and our understanding of who we are. Even if time isn't what we think it is, it's still the foundation of everything we know and feel. It's the thread that connects the past, present, and future. And without it, we wouldn't be able to make sense of anything. And perhaps that's enough. The mystery of time, its ability to both ground us and elude us, is what makes it so fascinating. It's a puzzle we may never solve, but one we can't help but try to understand. In the end, maybe it's the very act of exploring time, of questioning it, reflecting on it, and trying to make sense of it, that gives our lives their most profound meaning. Time may be a mystery, but it's a mystery worth exploring. And in that exploration, we find not only answers, but a deeper appreciation for the fleeting moments we have. Time, whether real or imagined, is the measure of our existence. And in that sense, it's more real than anything else we can know. So, as we continue to search for answers, let us not forget to appreciate the moments that slip by. For it is in those moments that we find the essence of what it means to be alive. Time might be an illusion, but it's the illusion that makes us who we are. It's the one thing that ties us all together, and it's the one thing we will never truly escape. And maybe, just maybe, that's exactly what makes it so beautiful. Subscribe for more mind-bending ideas like this, or watch the next video to keep questioning everything you thought you knew.